absolute value equation solving. So absolute value is a very special little stinker at times because if we don't think carefully, we miss half the answers. So if the absolute value of x equals 7, what are the possible values of x? Notice values. What do you think they could be? 7 and negative 7, because what absolute value actually is, if we kind of looked at it on a number line, is, hey, what numbers are 7 away from 0? And we all kind of know, well, 7 is 7 away from 0, but so is this. Because when you do distance, which is what absolute value is, distance is always positive. It's not like if I'm driving my car along my friend's house and then I drive backwards, it's going negative and my odometer is going backwards. That would be kind of interesting. But everything is still going forward. So we're looking for those types of values. But there are going to be instances that that's not going to be the case. But before I get too far ahead of myself, one more interesting one with a twist. If the absolute value of x equals negative 4, what are the possible values? Be careful. Can we go a negative value? Okay, we can't go, oh, Hardy spelling. We can't do a negative distance. So here's kind of why I showed that. If we run into problems that we get our absolute value on a side by itself and the equal side is just a negative number, that's not possible. It's going to be no solution. So that might pop up a time or two here, so we got to be ready. So when we get into solving these absolute value equations, we're always going to get the absolute value by itself on a side. And then we're going to make two cases because typically there's going to be two answers. But the biggest part about this, and the part that people tend to forget now and then, we've got to do the equal part to both the positive and the negative value of the number on the opposite side. And if there's a variable over there, it's the same thing. We're changing the sign of it. And we're going to solve both equations and then check for, extraneous solutions. That sounds so technical. Extraneous solutions occur when we did the math right, but the answer doesn't work. And this doesn't happen very often in math. Normally, if you do the right work, you get the right answer, and you're good. But here, we can do all the math right, and sometimes we may get an answer that just doesn't fit, sort of like up here with our negative there. And that's kind of the hint. Usually, it's the negative number that's going to cause a problem, but not always. So, solve the equation. Let's check, make sure we don't have some extraneous solutions. So here, I've already got my absolute values by itself. Okay, I don't have to do anything fancy. So two equations are coming here. So the first one, I'm just going to leave it alone. We're just going to drop the bars. Second one, we're just going to change the sign of our answer. But again, the absolute value bars aren't there anymore, so these are both going to be doable. Add my 9. Add my 9. But before I circle, I want to double check. Now, since I don't have negatives, I'm feeling pretty good that this is going to be okay. 14 minus 9 is 5. Yep, that's good. Okay. 4 minus 9 is -5, but again, the absolute value is a distance. It makes it positive, so 5 equals 5. They both work. So you're like, all right, not terrible, not terrible. Sure. So when we're solving these equations, to get the two cases or the two solutions, we're always going to set whatever's inside the absolute value equal to the positive number on this side, but also to the negative value, so we make sure we get both of the solutions and not just one. So that'll typically, yeah, it's going to seem strange that we're just randomly changing this into a negative, but it's really not random because both of them, when I plug them in, still work. And so one more regular one before we start throwing some twists in. So here, absolute value is by itself. So again, first time, just leave it alone. Second one, make sure to change that sign, because otherwise we're going to end up with the exact same equation. So minus my 7 divide by 2. Then same thing over here, minus the 7 divide. Oh, let's see what's going on here. Let's make sure. Okay, so let's try this out. If I plug in the -2, that'd be -4 plus 7 is 3. The absolute value of 3 is 3. Okay, that one's all right. Let's see, -5. 2 times -5 is -10. Plus 7 is -3, but the bars take care of the negativity. Okay. They were both negative, but they both still worked. Interesting. Interesting. And so that's why, again, we check. The feelers went up, which is a good thing to do with the negatives. But it doesn't always mean that it's going to be something bad. All right, now here we got to do a little work first. On the rest of them, we got a little bit of work. So I look, and I'm like, okay, got to get that 17 out of there first. So we're going to minus that out. I can't do my plus and minus thing until that's done. If I'd have done the set this equal and then those are absolute value bars. I usually make them a little more slanted because if I don't, it almost looks like I'm making it say 1y minus 11, and I don't want people to think that's what I'm doing here.
Maybe you can make them thicker.
I could, or I could do a different color maybe too.
Or you could use a Sharpie to make them extremely thick.
That's true.
And darker.
Absolutely. Might have to give that a run here on the next one. So once that's alone, now I do my leave it, and my switch it to a negative. Add it on over. Ooh, I gotta be careful here. Add it on over is actually gonna get us closer back to 0 here. All right, let's see. Oh, because here we had to minus 17 from both sides to get that isolated. So 23 minus 17 is where that 6 is coming from. So let's see here. 7 minus 1 is 6. 6 plus 17, 23, yes. -5 minus 1 is -6, but coming out of the absolute value, that'll be positive. 6 plus 17 also works. Like, dang, Hardy. Like, these extraneous solutions, do they exist, or are you just making up weird stuff? It's looking like I make up weird stuff so far, but I promise it does happen. It will. It will. All right, let's see here. I'm running out of problems for it to happen, though. Oh, let's see here. What do I have to do on 6 to get my absolute value alone? Divide by 3. Whatever we're doing to one side, we're doing to both. Okay, we're alone. We're ready to splitsy. I'll make up words. All right, let's see here. -8. -8. All right, let's see here. 5 plus 8 is 13. 3 times 13 is 39. Okay, we're good there. -21 plus 8 is -13. -13, well, absolute value would be +13 times 3. Still, 8 for 8. Okay. Our luck has got to run out here soon, right? We're going to see. Like, Hardy, why are you making us do the same thing twice? You're being a goof. Oh, not really. Hang on here a minute. Divide by my 16. Ruh-roh.
That's an issue.
Now, if I see this right away, wait a minute, absolute value always comes out positive, that's a negative. I, right at this point, before I do anything else, could say no solution. Yes, I've had negatives on the other side, but that's after we've split them up and gotten rid of the absolute value. But let's say you forget. Let's do a what if for a second here. Is all lost and I'm going to get this wrong if I don't think this through? No. So let me just say, like, okay, I forgot. So I'm going to split this. So r minus 5 is -2. R minus 5, I got to change the sign on this. Okay, I guess I'll make it +2. And I add my 5. And I'm just going along, and I add my 5, and I'm feeling good. And I'm like, okay, let's plug these in. 3 minus 5 is -2. Okay. Absolute value is 2. Oh. 16 times 2 is 32. That doesn't equal -32. That didn't work. Okay, let's try 7. 7 minus 5 is 2. 16 times 2. Wait a minute, the same thing's going to happen. Does 32 equal -32? It does not. Neither one works. Oh, it must be no solution. So if you're a creature of habit and you're just grinding along and you're like, all right, I'm going to keep splitting into 2. Here I go, here I go. And I don't see that. As long as I'm checking my answers, I'll still get the right answer. So don't let that concern you if you forget. It just means you're going to have a little work to do. There's nothing wrong with a little work. It doesn't hurt nothing. All right, one more to play with. Oh, don't get sucked in. I got it, Hardy. It's a negative on the right. There's no solution. Isolate this first because things can happen. If I multiply by -2 to get rid of the fraction,
It becomes positive.
it becomes positive, and we might be okay now. We're still going to do it and make sure, but hey, let's run this through, see what happens. So we'll keep it the first time. We'll change the sign of the answer the second. Add my 10 over. Add my 10 over. Oh, the moment of truth is upon us. All right, this one I might need to get myself a little side work here. This is a lot to be thinking in my head. So we got 22 minus 10 over -2. All right. 22 minus 10 is 12. 12 divided by -2 is -6. Okay, that one worked. We're good. -2. All right, -2 minus 10. -2 minus 10 is -12. But the absolute value bars are there. Hey. Okay. Nice. And we're good. So it doesn't mean that the only time you're going to get an extraneous solution is if it's negative on the other side to begin with. It just means it doesn't happen very often. So it's not something we really got to concern ourselves with a whole lot. Okay. So here's the deal. I think that's the end. It is the end of the notes for today. So we're going to flip over to the to the new practice here. And I know it's going to seem strange, like, Hardy, what happened to the first 8 problems? This is kind of weird. I zapped some of them out, so instead of having 2 sheets and going, hey, you really don't need to do the first page, they're so simple, I wanted to get you some challenges, but at the same time, I didn't want to go crazy. So I want to answer a couple of questions that people tend to have when we first start this. Now, do I still want to work through the process? Sure. But I will mention, when you have minuses inside the beginning, you leave that there. So like when you're splitting this up, once you've got this isolated, once we add the 11, keep it as 8 minus p on each side. Don't try to change signs or something. That'll kind of get you. But what I wanted to talk about is something we actually didn't do on the notes, but I want to make sure that we have an example. What happens if I get to something like number 13? You're like, wait a minute. The absolute value is isolated. That's good. But like now there's a variable on the other side. What's up with that? So here's how we're going to handle that. That's isolated. We're ready to go. So I just copy it the first time. The second one is where it gets interesting. So you know how when we were doing these before, we just take this answer and we change the sign. We're going to do the same thing here. Whatever is on the right side, we're going to change the sign on everything. So that positive x is going to become negative. That positive 1 is going to become negative. So basically what I did was I stuck a negative on the outside of the answer and said, okay, if I distribute the negative, I get negative x, I get negative 1. And I still can solve this just like I was doing the ones on the other side. I just got a little more work to do, which isn't a terrible thing. So let's get all the x's together. Just kind of work our way through here. And so once we kind of work through that process, I'm still going to check this, but I'll do it before I go to the next one. So if I plug in my 5, I got 2 places to plug it in this time. So 3 times 5 is 15, minus 9 is 6. That's the value of 6 is 6. 5 plus 1 is 6. Okay, that one worked. Now let's play over here, a little different. So let's see, get that out of there.
You put less x instead. Oh, never mind.
Okay. I know I do some kooky stuff at times. That's why I'm always on pause. I'm like, uh-oh. Let's see here. X equals 2. Let's see. 3 times 2 is 6. Minus 9 is negative 3. So the absolute value of negative 3 is 3. 2 plus 1 is 3. Okay. Both worked that time. So the other one I'm going to kind of work and get you set up on. I'm just looking to see. Yeah. Would be 16, just to kind of give you a heads up. It's still by itself. First, like here, I'd have to add the 5n first. But here, all set up and ready to go. So again, we'd set this up. Just copy the first time. And then the second time, just like we did up in 13, we're changing the signs on both of those, and then just going ahead and solving both of them. So the concept is exactly the same as if it's just a number. The only difference is now we got more variables to play with, so we got to move things around a little bit and get ourselves situated with that. So we're just finishing off the ones on this page. We're not going overly crazy here. I do not have the keys online yet. I have the physical one up here. Yesterday was crazy day in the copy room, so I'm going to try and get down there today and get that set, but otherwise I'll make sure I have them in here until I have that situated.